Well, guys, good morning. So very much to talk about. So why don't we have you gather up your stuff, and then we'll have our foundation set, and we'll be able to just talk through all of this. So guys, grab your notebooks. Please grab the homework that is due today. Please grab your periodic tables, and please grab something that you can take notes with and on. Guys, as you're getting settled, I appreciate those of you that are coming to me and saying, hey, I have this little yellow slip of paper that says I'm okay to go get my pictures taken. Guys, I don't need to see those. I mean, my students tend to be some of the most involved students in the school. This happens every year. So, guys, not surprisingly, the drill is this. When you need to leave, just excuse yourself. If you're on this side of the classroom, go out that door and cut through the lab. You'll have to return through this door because that door is locked through the lab. But guys, when you need to leave, go. When you're done, come back. And then guys, understand that you will be missing significant material in your absence. It will be screencast, and it will then be your responsibility to catch up. Now guys, please understand, when you come back, that is not the time for you to catch up. Please don't turn to the person next to you and go, what did I miss? Because the problem is then that the person sitting next to you is now missing because you missed. So guys, it's your responsibility to get caught up. So with that said, guys, join me at the board because there's like 11 things going on right now that we need to talk about. So probably the way to start would be to start with today. So guys, we are about to review the orbital filling homework assignment. I know that we've talked on several occasions at the beginning of this quarter about the idea, guys, that many of you got B's instead of A's because you didn't turn in your homework. Well, guess what? More than a few of you didn't turn in the last assignment. So guys, apparently that idea is lost on you, which is completely fine, but just understand when your grade doesn't end up being what you thought it should be, understand it's sort of comforting because you'll know why. So guys, if you'd like to fix that, please remember that tonight by midnight, you have a deadline to turn in the orbital filling assignment, which we're about to go over. Then guys, what you're going to find is today the material that we are going to cover builds on what we learned. We're actually going to start by drawing a few orbital diagrams and using that as the foundation as we move forward. Then guys, all sorts of deadlines coming up. So guys, test is on Monday. What that means is your last opportunity to turn in any late homework, just homework, but any late homework for this unit is when the bell rings on Monday morning. So guys, if you're missing homework, it's got to be turned in then. Guys, in addition to that, please remember that this is also when the extra credit is due. And guys, to help you better understand what this is all about, what we did is actually, where did it go? We posted, right here. No, yeah, that is it. So guys, what I did is I actually posted the grading rubric for the extra credit. So if you're curious to know how you'll be graded on this extra credit, we already talked about this. A percentage of it is that they're correct by shape and size. In addition to that, you need to represent the 1s through the 4f orbitals. Then approximately a third of the points is just for the quality of your work. But guys, that gets you up to 90%. If you want the last 10% of extra credit, that will be based on originality, and that basically means it can't look like one of these. It can be similar, but it needs to be original. So guys, these are due the day of the test. If you don't get it done, that's fine. We're not turning them in late. So these are due on the day of the test. So guys, with that said, one more thing I want to share with you, and then we'll go over the homework. So guys, you'll notice that the test is on Monday. What I want to do is I want to show you the last page of the test. You ready? So guys, notice the study guide is posted. I'd encourage you to go over it. But then guys, you see this link that says optional practice. When you click on that, guys, this is the last page of the test. The last page of the test is all handwritten, and you are drawing, first of all, orbital filling diagrams. You'll be doing 3, I think. Then guys, after that, you're going to be drawing what are called noble gas abbreviations and then Lewis dot diagrams. That is what you're learning today. And so guys, Ms. Call and I put together an optional review assignment. If you would like to do this, the answers are posted. We're not turning it in. But guys, the bottom line is if you can do this, you're ready for the last page of the test. And then all you have to do is review the conceptual stuff. So guys, that's where we are. So we talked about turning in homework today. We talked about extra credit. We talked about the test. Guys, anything related to the calendar that we need to go over in greater detail? You guys all good? Okay. Then guys, with that said, let's take a look at the homework. So we have got the orbital filling assignment. You guys remember tonight, you are going to be, let me get my writing stuff. Guys, you are going to be agreeing to a statement that's actually two things. That it's done completely and that you got all of your questions answered. So what do we need to talk about in order for you to be able to say yes to both of those questions? Please. Are we on the back? Let me just do the, guys, any questions on the front? You okay? The 1S are spheres, the S's are spheres, the P's are dumbbells. It asks you to describe them, but I drew them because I thought that would be better. Remember that these are oriented 90 degrees to each other because of repulsion. This was just a retelling of your homework. And then guys, relative to this idea of writing out the orbital filling, please understand that you will not be doing any of the orbital filling diagrams for the F sublevel. This is in fact the order that they fill, but we will not take you down into this region with orbital filling diagrams, so you don't have to get real terribly caught up in that. Are we okay first page? Where did you want to go second page? Okay, is that, oh wait, go ahead. Yeah, no, that's why we ask questions. Yeah. Beautiful question. And let me tell you a question that you're going to see on the test relative to this. So looking at iron, you're going to see questions in multiple choice that say something like this. Which of these electrons was the last one that you placed? So let's talk about it. So are you okay with the idea that iron is down here in the 3D? Is that okay? So iron is here. It's in the fourth energy level, but it's D minus 1, so this isn't 4, it's 3. So we go 4S and then we go 3D. Is that okay? But remember, we have to start all the way back in the 1S. So we go 1S, 2S, 2P, 3S, 3P, 4S, 3D. And that gets us to iron. But then, as we start placing these electrons, let me bless you. As we start placing these electrons, I'm just going to start with electron 19 that is in the 4S. So we go like this. And I'll write them underneath. So electron 19 goes there. Electron 20 pairs up. So we have to fill a sublevel before we can move past it. But then when we get down here to the 3D, there's more boxes in that sublevel. So that was number 20, right? So then we go number 21, which is there. But now where does 22 go? The next box over. So 22 goes here, 23 goes there, 24 goes there, 25 goes there, and then they come back and pair up. So let's actually do that. Let's go back and place all of these electrons, starting with number 1. So number 1 goes here. Where does number 2 go? Paired up, right? So number 3 goes here. Number 4 pairs up. Now they spread out. So they go 5 and 6 and 7, and then they pair up 8, 9, and 10. So anytime is it wrong that I want to kill you? Okay. Just take it and go. Go, bring it back later. Does that make sense now? So we go here and then pair up and then spread out, spread out, spread out, pair up, pair up, pair up, and then we just keep going. Absolutely. Yep. So in the S, they have to pair up because there's nowhere else to go. In the P, they spread out, then come back and pair up. In the D, they spread out and then come back and pair up. Yeah. Exactly, yeah. So, and that would actually be element 1, 2, 3, 4, 5. So that would be manganese. So if we were doing manganese, we would go 21, 22, 23, 24, 25, and you're done there. Is that okay? Good. Guys, other questions on this assignment? Y'all good? You're sure? You'll ask if you're not, right? Okay, so guys, if we're done with this, what you need to do is grab your periodic tables and grab your that notes piece that I ask you to jump on. And guys, this is your opportunity. So today what we are going to do is we are going to look at 3 things. So if you're in the habit of titling your notes, you want to go ions, NGAs, and LDSs. The date today is the 5th. And again, guys, the topic for what we're doing today are ions, NGAs, and LDSs. Now, guys, please remember, as I showed you a second ago, this is 2/3 of the last page of the test. Noble gas abbreviations and Lewis dot structures are 2/3 of the last day of the test, or the last page of the test. But what you're going to find out is they all build on your ability to do orbital filling diagrams. So guys, here's where we're going to start. Draw the orbital filling diagrams for these 4 elements. Guys, if you look at this and you're saying to yourself, this is easy, I know how to do these, I really don't have any questions on the homework. Not that I just didn't care to ask them, but I really don't have questions on the homework. Guys, if this is easy for you, do them. Because obviously this is the foundation upon which we're going to build these new ideas. But guys, also as you get into these, if you're stuck, now's a great additional opportunity to ask questions. By the way, as you're drawing these, get them all on a line. Do sodium on a line. Do chlorine on one line. Make them wide. Don't drop down a line. You'll be really thankful if you do. Guys, as you're drawing these Lewis dot structures, or these orbital filling diagrams, let me whisper in your ear a little bit. There are a couple people in this room that did not complete first quarter. And at the end of first quarter, I engaged in conversations with you about the possibility of wrapping things up because you were gone with COVID and stuff like that. I felt a responsibility to do that. And of those in this room for which that was the case, a couple of you I have not heard anything back from. Please understand that next Friday it's done. Guys, my invitation to you to get caught up was not open-ended. It was never intended to be. And from your communication, it seems like a couple of you just aren't interested in following through, which is fine. But understand, guys, that if this work is not done by next Friday, you just lost the opportunity. So communication is critical. Please come and talk with me if you need. But next Friday, we're just going to say, we're done. So, guys, if you're a little stuck, maybe, let me prime the pump. Here's sodium. Please understand that if yours don't look like mine, they won't be right on the test. The 1S, the 2S, the 2P, the 3S goes across the top. They're spread out. Spaces between them. The boxes are drawn underneath. The arrows are represented by up and down, indicating their spins are opposite. This is what they should look like. Yeah.
So, my dad told me to strategy or whatever.
Yeah.
Writing gas like
like I did there. So do you mean like this where I gave you the 11?
Well, no, underneath, like 1x, I got a 2.
Oh, that's totally fine. So you're just, if I understand, you're doing like 2, 2, 6, 2, or maybe 2, 2, 6, 1.
Yeah.
That's awesome. Yeah, to me that feels like extra work, but if you feel it's beneficial, that's great. Yeah, because actually, Sam, what you're going to find out in a minute is if you're writing them down here, if you're going 2, 2, 6, and 1, if you take these numbers and write them up here, you just did noble gas abbreviations. That's all a noble gas abbreviate. The next thing we're going to learn is just those numbers up here. So yeah, so you're actually ahead of the game. So guys, once again, questions on this as you're moving through them. You're probably then into chlorine. So let me share that one with you. Would it be distracting if I just gave you all the answers? Is that okay? Is that all right? So guys, copper and arsenic. So work through them, compare as you go, ask questions as you need. And then guys, what I want to do once we're all settled on these is I want to spend a couple minutes and show you some tricks. I'm suspecting a lot of you figured these out. But I want to show you some tricks that'll help you be extra confident that you're correct. And then guys, frankly, today goes pretty quick. What we're going to do is we're going to take these things and make them frankly easier. Well, at least shorter. Are you like me, or are you sick of drawing arrows? The beautiful part is that after this test, you won't have to draw arrows anymore. Oh, sorry. Arsenic. Number 33. Claire, how's it coming? Are you good? Are you good on these? Awesome. I like it. Guys, also, if you have questions about the extra credit, please let me know. I've had several people that have come in and done the whatabouts. And I should probably mention this too. Understand, guys, that these are pretty, but they're not necessarily right. All these things that I chose to stick up on the wall doesn't mean they're right. It just means they were fun to look at. So don't necessarily copy them perfectly if you're planning on something like that. You guys all done? Do you need another second? All right. Hi. Thank you. Oh, got it. Okay. Say that, was that, Isaac, was that you? Oh, say it again. So when you say round, do you mean spherical? Like three-dimensional, right? Keep going, what? Absolutely, yeah, and I mean, we know it mathematically, we know it experimentally, but the thing that's really interesting about that, have you ever noticed that in nature, there are very, very few things that are square, right? Cells are round, trees are round, the sun is round, the earth is round, I'm round. Sorry, I couldn't miss that. For the most part, things tend to be round. The reason is because it actually, I don't know if you've done this in biology, it actually minimizes surface area and maximizes internal space. There's some really interesting stuff going on in there, but we live in a world that likes to be round. squared edges are not favored in pretty much anything on Earth. And there's reasons, but that includes electrons as well. It's kind of a weird thought if you think about it. We don't see a whole lot of square. Have you ever thought about that? Exactly, precisely, right? Unless it's man-made. All right, how about now, guys? You all good? Any questions about the stuff that you just drew into your notes? You're okay? So guys, allow me, if you would, for just a second to share a trick with you. It sounds like you're feeling moderately comfortable with this, but guys, let me show you a really quick way to error check to make sure that you're okay. And guys, it goes like this. For example, if you look at sodium, join me on the periodic table. Guys, look at where sodium is. It's the first element in the 3s sublevel. But guys, you'll notice that there's one electron in the 3s sublevel. Those are connected. So now let's take a look at chlorine. Guys, chlorine is at the end of the 3p sublevel. It's one box away from the end of the 3p sublevel, but you'll notice that there's one empty space. All of this stuff is related. So for example, if you look at copper, copper is one box away from the end of the 3D, and there's one empty space. And then guys, looking at arsenic, you'll notice that arsenic is the first, second, third element in the 4p, and you'll notice that there's 3 electrons in the 4p. So guys, all of those things tie together. So as you're doing these, it's a great way to error check. So guys, in a second, we're going to take these things and we're going to simplify them, but let's make sure we're all okay. Any questions about orbital filling diagrams? Y'all good? Okay. So guys, let me set the stage then for the rest of the day. Everything that you're going to learn in the next probably 30 or 40 minutes is all skills based. No concepts. So guys, the bottom line is this. Don't take notes. I know that that feels weird, but guys, please just trust me on this. Don't take notes. What you do want to write down are the examples of what I'm about to teach you. No concepts, only skills, only write down the examples. You guys okay? All right. So guys, what I want you to do then is this. Keep your eye on chlorine. 1s, 2s, 2p, 3s, 3p, one empty box, that's chlorine. So gang, the first thing that we need to do is we need to come back to an idea that you learned in the last unit. Remember when we learned about ions? Guys, how do we remember, and we did those charts and we had protons and neutrons and electrons. And guys, when we turned atoms into ions, what did we do? What did we mess around with to make an atom an ion? The number of electrons. So guys, ions are atoms with a charge. This is all review, don't write it down. And remember the idea that cations are positively charged, and we form those by removing electrons, and anions are negative, and we form those by adding electrons. And then guys, we started doing things like this, and we said, hey, yo, this is a chlorine atom, and chlorine's got 17 protons and 18 neutrons, and it's got 17 electrons. And then we said, okay, what do we do if we want to give chlorine a +1 charge? And we came along and we said, all right, if we make chlorine a +1 charge, guys, what do we do to chlorine to make it +1? Not add a proton, because then it's not chlorine. What do we do? Take away an electron, and we make this 16, and there you go, and that's chlorine with a +1 charge. Is that all coming back to you? Guys, here then is the conversation that we need to have right now. So to give chlorine a +1 charge, we take away an electron. But guys, join me, because here's the question. If we're going to take away an electron, which one? Because guys, now we understand that these 17 electrons are not just puddled together, and there's 2 of them in the 1s, and then the 2s and the 2p and the 3s and the 3p. And so guys, the question then becomes, which electron are we going to take? Alexis, this comes to your question. So guys, back when we graded homework. So guys, which electron do you suppose we're going to take away? The last one that we added. So guys, the idea is this. The last electrons that we added are in the p. But guys, let's call this electron 1, 2, 3, 4, and 5. Guys, which was the last electron that we added? Electron 4, and that is the electron that goes away. Do you see how that now becomes important? So guys, the idea then is this. We pull the electrons out opposite the order that we put them in. But there's limits to this. And guys, this is the idea that you need to understand. Again, don't write it down, but when we add or remove electrons, they always come from the highest. And guys, this is critical you get this. They come from the highest s and or p orbitals, and these are called the valence electrons, and that means on the outside. So guys, the fundamental rule is this. When you add and remove electrons, it's always the highest s or p orbitals, and those are called valence electrons. So guys, here's what I want you to do. Go to your diagrams and guys, underline the valence sublevels. So what does valence mean? It means highest s or p. So guys, this is the valence sublevel for sodium. Please underline it with me. Now guys, what about this? What about the P? Well guys, the P is not valence because 3 is higher than 2 and it's only the valence electrons. It's once we get the 3, we don't go down into the 2 because that's not highest. So let's keep this idea going. So guys, these are valence electrons in chlorine, but so are these. So how does that work? Well, they're both in the third energy level. So the 3s and the 3p are the highest s and p electrons, and that makes them the valence electrons. And those are the only ones we can mess around with. So guys, where are the valence electrons in copper? Looking at your diagram, where are the valence electrons in copper? 4s. These are the valence electrons in copper. D electrons are never valence. F electrons are never valence. Guys, it's only the highest S or P. And in this case, that's the 4s, because 4 is the biggest number, and the Ds will never be valence. So guys, if that's the case, please underline the valence electrons in arsenic. Do it in your notes, and then we'll talk about the answer. So let's take a look. So guys, the fourth energy level, 4p, are valence electrons. But the question is, are there any others? Guys, the answer is yes. The Ds are never valence, but guys, the 4s are. So it's the highest, I need to unlock that. It's the highest S or P, and in arsenic, that would be the 4s and the 4. So guys, this is critical you understand this. What questions do you have? You okay? You're good? Okay, then let's start playing with this. So guys, here we go. We've now underlined our valence electrons. Now let's start to mess around with this. So guys, what are we going to do? And I would encourage you to write these down with me in your notes. What are we going to do if you want to make sodium -1? That means we add an electron, right? Where does that electron go? Right in the 3s. And if we wanted to do sodium with a -1 charge, that electron goes there. But guys, check this out. What if we want to go sodium -2? What are we going to do? How many electrons do we need to add? 2. Well, 1 goes here. Where does the other one go? And the answer is it can't. There's nowhere to put that second electron, so sodium cannot go -2 because it doesn't have room for 2 electrons. Yeah? You're brilliant. Let's do it. You ready? Here we go. So now let's go sodium +1. So guys, if we go +1, we take an electron away. Which one do we take? We take away that one. Now guys, what if we want to go sodium +2? Guys, we can't. Sodium cannot go +2, just like you said, because we can take this one away and make it +1, but these are not the highest S or P, and we can't mess around with them. So guys, when you see a question on the test that says, what are the possible charges for sodium, do you understand that the answer is between +1 and -1? Because those are questions that you need to be able to answer. So let's keep going with this and let's look at chlorine. So guys, looking at chlorine, can chlorine go -1? Yes or no? Give me thumbs up or thumbs down. Can chlorine go -1? It can. Where does the electron go? Right in the 3p. So chlorine can go -1. Can chlorine go -2? Because there's nowhere for that second electron to be. So guys, chlorine cannot go -2. Now guys, what about this? Can chlorine go +1? Be careful. It can, but guys, be careful. Which electron comes out? That dude right there. What if it goes +2? Can it do that? Yeah, this electron right there. What about 3 or 4 or 5? Sure, 3, 4, 5. Can it go +6? Yes, because guys, it's the 3s and the 3p, so it can go +6. Can it go +7? Yeah, this guy comes out. Can it go +8? It can, because it doesn't have an 8th electron. So guys, now let's go down to copper. So looking at copper, let's go copper -1. Guys, show me thumbs. Can copper go -1? No. Why not? Guys, this is not valence. It's only the highest S or P, and that is not the highest S or P, so copper cannot take in electrons. So guys, what about this? Can copper go +1? Yeah, where does the electron come from? Right there out of the 4s. Can it go +2? Absolutely. Take that electron away. Can it go +3? No, it cannot. Good? So guys, one more to go. Let's go down and look at arsenic. So what about this? Arsenic -1. Can it do it? Yeah? Right here. -1, -2, -3. What about -4? Can happen. Now guys, what about the other direction? Can we go +1? Yeah, so here we go. +1, you bet. +2? Absolutely. +3? For sure. +4? Yeah, over here. +5? Yes, not +6. Guys, do you see it? Okay, so that is thought number 1. How do ions form? Gaining or losing electrons. But guys, it's critical you understand that these electrons are gained or lost from the highest S and P. Good? Okay. Now guys, we got 2 more things to do, and this just makes these things simpler. You ready? So guys, if you did the homework last night, my guess is you found these things frustrating. And you were good at them, and you found them frustrating. Because guys, by the end of the homework assignment that you did, you are so sick of drawing boxes and arrows that you just want to die. So guys, what we're going to do is we're going to get rid of the boxes and the arrows. So guys, let's talk about this just to make sure you understand the problem. So guys, obviously I typed these rather than drawing them, so let me let you in on a secret. How do I type these things up? The answer is I draw the biggest one. So in the homework assignment, what I did is I drew the very last one. And then what I do, guys, is I copy and paste it for the number of them that I need, and then I just delete out the stuff that I don't need to make it small enough to be the smaller elements. Guys, these are so redundant that it's always 1s, 2s, 2p, 3s, 3p, and it only changes down at the end. And the arrows are ridiculous. So guys, here's what we're going to do. Again, don't write any of this down. But guys, I am now going to teach you what are called noble gas abbreviations. Guys, these make these diagrams easier in actually 2 ways. First of all, we're not going to draw arrows anymore. instead of drawing arrows, and Sam, this is what you and I were talking about, instead of drawing arrows, we're going to use superscripts to count the electrons. But then, guys, the other thing we're going to get rid of is we're not going to start at hydrogen every time. We are now going to allow ourselves to start at the closest previous noble gas. Why the noble gases? The guys on the red on the end, because they're all full up. So guys, we are now no longer going to have to go back to here every time. We can start at any of these. So guys, let me show you how to do this. Go back to your stuff that you already wrote down. Here's what we're going to do. We are going to turn these into noble gas abbreviations. This is so much easier. Guys, do this with me in your notes. So for example, sodium is right here. Guys, looking at your periodic table, or join me if you want. Sodium is here, so we need to go back to the previous noble gas, which is what? Neon. Good. So neon is at the end of the 2p. So guys, the idea here is that all of this right here is the electron structure of neon. So instead of writing out 1s2s2p, what we're going to do is we're just going to throw down some brackets and we're going to write neon. Do this with me. Then guys, we're going to make it even easier. Check this out. In addition to neon, we've got the 3s sublevel with one electron, and we're done. That is how we're going to represent neon. That's how we're going to represent sodium. So guys, let's do another one together. So chlorine is element number 17. Can we go to argon? No, we got to go back again to neon. So guys, all of this again is neon, and then in addition to that, we've got the 3s with 2 and the 3p with 5, and we're done. That's all there is to these. That's awesome, McKay, because what I'm doing right now is I'm counting electrons, but if I were to do it on the periodic table, I would be counting boxes. So it's the 3s with 2 and the 3p with 1, 2, 3, 4, 5. Yep. So, guys, do you see it? What do you see? Look really close at your periodic tables. Normally by now somebody goes, ah! Do you see it? Say it again, son. Yeah, guys, all these are on the periodic table. Do you see? Go look at sodium and look right below the Na. See what it says? Neon 3s1. And guys, go over to chlorine. See what it says? Guys, all these are on the periodic table. It's normally at this point that my students think that the dollar they spend on their periodic table is money well spent, but I gave these to you, so all the better. But guys, all of these are on the periodic table. But now guys, let's do copper. So guys, join me, don't miss this. Join me on copper. So guys, for copper, which noble gas do we go back to? Argon. So argon is at the end of the 3p. So guys, all of this is argon. So we're going to go argon, and then in addition to that, we're going to go 4s with 2, and then the 3d with 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you see this? Because guys, we have a problem. We just said that copper is argon 4s2, 3d9. Look this up on your periodic table. What do you have? You have argon 3d9. You have argon, tell me again, 3d10, 4s1. So guys, here's where you've got to be careful. Let's talk about this. This is what we are saying copper should be. This is what the periodic table is telling you. So guys, the bottom line is this. If you blindly copy these noble gas abbreviations off the periodic table, in many instances, you're going to get them wrong. Let's talk about why. So guys, this is actually what happens in copper. One of these electrons that is in the 4s jumps into the 3d. That's why it's 4s1, 3d10. One of these electrons actually jumps between the s and the d. And that shouldn't be surprising because of the overlap between them. But guys, this happens all the time, and I don't expect you to understand this until you come back for AP next year. So this is what copper actually does. This is what I want you to understand about copper. So if you were to copy copper off the periodic table, it would be wrong. In addition to that, notice that on the periodic table, they put the D before the S. Guys, the reason is because on the periodic table, they like to put the valence electrons last, and we're not going to do that. We are going to put them in the order that they fill, and as a result, we, for copper, would put argon 4s2, 3d9. So guys, again, the bottom line is use the information on the table as a reference, but don't rely on it because many times it'll lead you astray. You guys good on these? Questions about noble gas abbreviations? They're better, right? You'll see. It's in the homework. But guys, do you understand that while these seem simpler, we just actually made more work for ourselves? Because guys, imagine if I came to you and said, draw the noble gas abbreviation for copper. Well, the only thing that you know how to do right now is to draw the orbital filling diagram and then convert it into the noble gas abbreviation. So guys, how are we going to do this? How are we going to write noble gas abbreviations without doing the Lewis dot structures first? Write these into your notes. Skip 2 lines between them. Mg, Ga, I-1, and Sr plus 2. So guys, the question is this: how do we draw these without doing the orbital filling diagrams first? These are examples you need. So let's do this together. So you ready? Magnesium is right here, element number 12. Guys, which noble gas are we going to go back to? Neon. Write it down. Do these with me. So neon, and then guys, check it out. In addition to neon, we've got 1, 2 electrons in which sublevel? 3s with 1, 2. So it's just neon, 3s2, and you're done. That's all there is to it. So now guys, go ahead, London. Why do we go back to neon? So the reason that we use the noble gases as the places that we can go back to is because these are completely full. Their S's and their P's and their D's and their F's are all full up. So it kind of provides like a bedrock starting point. So we can say magnesium has the all full up electron structure of neon plus these 2 electrons on the outside. So it just provides like a firm place that we can fall back on. Is that okay? So guys, let's do gallium. Gallium is right here, so we're going to go backwards to argon. Now, in addition to argon, we've got these 2 electrons which are in the 4s. So that would be 4s2. Again, guys, we're going to gallium. Then in addition to that, we've got all of these electrons which are in the D. But remember, it's the 3D. So it's 3D, 2, 4, 6, 8, 10. And then, guys, the last electron that makes gallium would be 4p with 1. And so that would be 4p1. Does that sit okay? Hey. Questions there? Okay, then guys, let's get into making these into ions. So now we're going to draw their noble gas abbreviations, but now we're going to add and remove electrons, making them ions. So guys, at first, I would encourage you to ignore the charge, draw the noble gas abbreviation, then mess with the electrons to make it charged. So guys, iodine is down here. We're going to go back to krypton. Then, in addition to krypton, we've got the 5s with 2, the 4d with 10, and the 5p with 1, 2, 3, 4, 5. So it goes 5s, it's not an s, 5s2, 4d10, 5p5. Now, if we want to make this a -1 charge, we have to add an electron. Where does it go? In the 5p, and we just turn this into a 6, and we're good to go. Now guys, what if we wanted to pull electrons out of this? What is the most electrons we could pull out of iodine? Well, sorry, let me make this back into a 5. Guys, what are the most electrons we can pull out of iodine? 7. Because there's 5 in the 5p and 2 in the 5s. Remember, it's the highest S and P, so we could pull electrons out of the 5s. Okay? So now, guys, let's go down to strontium and let's look at this. Strontium, I can never find. Where is it? Oh, it's over here. So, guys, strontium is over here, and so we've got krypton and then 5s with 2. I'm going to draw it up here so you can see it better. So, guys, this is krypton, and then in addition to that, we've got the 5s with 2. So that's krypton. But now what if we want to make it krypton with the +2 charge? What do? Take away 2 electrons. Now guys, the question is this. It's only got 2 valence electrons, so when we take those valence electrons away, the 5s becomes empty. How do we represent that? Well guys, these are your options. You could put 5s blank, and that's just fine. You could also put 5s 0, and that's fine too. Guys, the thing you cannot do is this. Do not erase the whole 5s. You can either put 5s blank or 5s 0, but don't get rid of the whole thing. So guys, we are 2/3 of the way done unless you all have questions. So anything about noble gas abbreviations that you need to talk about? You guys okay? Guys, we've got one more to go. And these are even simpler. Again, don't write down the notes, but we will write down the examples. So guys, the last thing that we need to talk about are what are called Lewis dot structures. So guys, watch really carefully because this could get weird if you miss it. So guys, here's the deal. In Lewis dot structures, all you represent are the valence electrons. So guys, pause. That word has meaning to you now. Which electrons are the valence electrons? Highest S and P. So guys, those are the only electrons that these represent because those are the electrons that come and go. So when we draw Lewis dot structures, we only draw the valence electrons. Now guys, watch this animation because this will really help you. So we understand that the valence electrons are the highest S and the highest P. Yeah? But now guys, remember the way that we place these electrons. Electron 1 goes there. Where does electron 2 go? Paired up going down. Now guys, electron 3 goes there. Be careful, where does 4 go? Next box, 5, next box, then pair them up, pair them up, pair them up. Right? Guys, if that made sense to you, you can draw Lewis dot structures, but for one little twist. Guys, what we're going to do is this. We're going to take the S and the 3p orbitals that are the valence orbitals, and instead of drawing them in a line, we are going to wrap them around the abbreviation of the element. So guys, this is fictitious element X. And here's how you're going to picture this. Guys, imagine above the abbreviation is one box, and we'll call this the S. Then guys, the p orbitals would wrap around that 1p, 2p, 3p, so those are our 4 valence orbitals. Now guys, let's place the electrons, just like we did here. So there is Well, and I should say we don't actually draw the boxes, but we imagine them. So guys, there's electron number 1. Where does electron number 2 go? Where does electron 2 go here? Paired up, so it goes paired up. Then guys, remember 3, 4, and 5 go unpaired. So 3, 4, and 5 go unpaired. And then coming back, 6, 7, and 8 pair up. You get the pattern? So guys, if you understand the pattern, and if you don't, watch and you'll see. Guys, let's go back to your stuff. Go up, and we're now going to draw the Lewis dot structures for these things. So guys, here we go. We're going to do sodium. So you're going to go Na. Write down the abbreviation. Now guys, ready? Of these electrons, which is the only electron that's valence? Where is the only valence electron? 3s. How many electrons are in there? 1. Draw a dot. You're done. Because that's it. That's the Lewis dot structure for sodium. Now guys, let's do chlorine. Chlorine is Cl. Now, which are the valence electrons in chlorine? The 3s and the 3p. So guys, just watch me do this once, would you? So we go 7 electrons, 2 plus 5. So we go 1, and then 2 pairs up, just like the arrows. Then we go 3, 4, and 5 are unpaired, and then 6 and 7 pair up. Is that okay? By the way, guys, if you're curious, and maybe some of you see this electron right here in sodium? See this space right there in chlorine? They link together like puzzle pieces, and that's how table salt gets formed. That's what we're doing in the next unit. Aww. All right, so here we go. We are now going to do copper, which is Cu. Now, guys, let me throw a little curveball your way. Well, let's establish the idea first. Which of these electrons in copper is valence? Just the 4s. How many of them are there? And they're going to be paired together, right? But guess what? It doesn't matter where you put them. The s does not have to be on top, and the p's don't have to be left, right, and bottom. You can call any one of them the s that you want to. The only way that you could screw up copper is if you did this. Why is that wrong? Yeah, the s electrons are paired up. Is that okay? So now, guys, let's do arsenic. So I'll do this up here so you can see it. So guys, arsenic has how many valence electrons? Careful. We got 3 here, right? But we've also got 2 there. We got 5. So guys, let's do this. Let's just say that the S is there. So there goes number 1. Doesn't really matter where we put it, but number 2 has got to be paired up. Then what about 3, 4, and 5? Spread them out. 3, 4, and 5. What do you think? Yeah? So guys, we got one more thing to talk about. These are great, but again, we drew these Lewis dot structures based on the orbital filling diagrams. And that's not less work, it's more. So guys, how are we going to draw the Lewis dot structures without drawing the orbital diagrams first? Well, guys, do this with me. How many dots does sodium have? 1. Find it on the periodic table, element number 11. Now, guys, what about this? How many dots does chlorine have? How many dots does chlorine? Join me at the board. How many dots does chlorine have? 7. Find it on the periodic table. Find its location. Then, guys, let's skip copper and go down to arsenic. How many dots does arsenic have? 5. Find it on the table. Do you see the connection between the number of dots and the location on the table? Guys, join me. How many dots does sodium have? 1. How many dots does chlorine have? 7. How many dots does arsenic have? 5. Do you see the connection? Guys, the location, the column location on the periodic table tells you the number of dots. So guys, look at sodium. Sodium is in the first, we call them groups, the first row, the first column. So guys, sodium is here and it has 1 dot. So do all of these. Then guys, magnesium and all of these dudes have 2 dots. But now guys, look at where chlorine is. Chlorine is in the 1, 2, 3, 4, 5, 6, 7th column, and it has 7 dots. And arsenic is in the 1, 2, 3, 4, 5th column, and it has 5 dots. So guys, the column that it is in tells you the number of dots that it will have. But guys, what about copper? How many dots does copper have? 2. But look at where copper is on the periodic table. Guys, which sublevel is copper in? The D. And the D is never valence. So guys, what that means is that copper's valence electrons are from the 4s, and all of these dudes right here will only have 2 dots because their D electrons are never valence, but you have to fill the S before you get to the D. So guys, it goes like this. 1 dot, 1 dot, 1 dot, 2 dots, 2 dots, 3 dots, 4 dots, 5 dots, 6 dots, 7 dot, 8 dots. So let's do this and then we're done. So guys, let's do these. Going back to the ones that we sort of looked at previously, guys, magnesium is Mg. And then we got 2 dots. Guys, doesn't matter where they go. Not so long as they're paired. Let's just put them over here. By the way, guys, and this is important, on the test, do not draw your dots on my abbreviations. Do them by rewriting them. You'll see why in just a minute. So now, guys, let's do gallium. See gallium right here, number 31. How many dots? Yeah, exactly. Good for you, Alex. Guys, this dude's going to have 3 dots. What do you know about the first 2 dots? They're paired up. Doesn't matter where they go, but they're paired. And then, guys, the 3rd dot is on its own. Yep. Correct. So these are the 2 electrons in the S, and that's the 1 electron in the P. Yeah, good for you. So guys, let me now explain to you why you can't use my abbreviations. Guys, look where iodine is. It's got 1, 2, 3, 4, 5, 6, 7 dots. But what if we want to make it -1? Do we add or remove 1? Add 1, and that would give it 8. So when we do iodine, we go 1, 2, 3, 4, 5, 6, 7, 8. That would be iodine minus charge. Just a second. But now guys, watch this. If you go like this, and if you put minus 1 on it, it's now wrong. Do not put charge in your noble gas abbreviation or in your Lewis dot structures. So guys, that's the reason you can't draw your dots on my abbreviations, because if the charges are there, it makes them wrong. Do not put charges in your Lewis dot structures. You okay? Sorry, cut. Okay. So guys, don't put charges in your Lewis dot structures. Okay. So again, let's keep going. So selenium then, over here, how many dots is that dude going to have without a charge? I think it's 6, right? 1, 2, 3, 4, 5, 6. Because here's where we got to be careful, because we're going to go 1 and 2, 3, 4, 5, and then 6. Now, we've got to make it +1, so we've got to pull an electron off. Which one do we take? The last one that we placed, which is one of them that's paired. So guys, we would either pull this one off, or technically we could pull one of those off. The trick is you always want to unpair electrons first. So to make this +1, we would pull off one of the paired electrons. Then guys, last one and we're done. Calcium is in the second group. It's got 2 dots. But then guys, how do we make this +2? Take them away. And so this would be calcium with a +2 charge. What do you think? Is that all okay? So guys, here then is where we are. You have homework assignment number 4. Grab your homework packets. We've got about 10 minutes. You're going to get at least half of this done. So guys, go back to, assignment 5. So guys, let me offer you a little insider tip. You ready? So you now understand that the last page of the test is going to be orbital filling diagrams, noble gas abbreviations, Lewis dot structures. Guys, read the instructions for assignment 4. You'll notice that it says, write the noble gas and Lewis dot structures for these atoms and ions. Now guys, here's the risk. If you follow these instructions to the letter of the law, you will write the noble gas and then the Lewis dot, then move down, noble gas, then Lewis dot. But the problem is this. If you do it that way, there's a very real chance that you're training yourself, hear this, training yourself to not be able to do the Lewis dot structures without doing the noble gas first. This would be my suggestion. On the first page, do the noble gas abbreviations first. On the second page, do the Lewis dot structures first. That way you know that you can do one without the other. So guys, we will go over this the day of the test. It will then be due that night. So guys, allow me to revisit for you all the things you should be thinking about. Tonight, before midnight, you have a homework assignment to turn in. Then on Monday, you'll have this homework assignment turn in and an extra credit project to turn in if you choose to do so. In addition to that, guys, thank you. In addition to that, guys, if you are wanting, I hope you are, if you're wanting to study well for this test, guys, going out to our website, again, on the day of the test, you'll notice that it says study guide. Guys, go over the concepts on the study guide. But then if you want additional support on the last page of the test, you'll notice it says optional practice. Guys, that's assignment 5 in your homework packet. Turn back another assignment. See assignment 5 there? Guys, it looks just like this. You don't have to print it. I gave you a copy of it. And guys, the answers are right here. You see it there? It's there, right? Oh, I'm sorry, assignment 6, not 5. I'm one off. It's assignment 6. Oh, it's not even numbered. It's the last page of the packet. So guys, the bottom line is this. We are not turning this in. We're not turning this in. But guys, if you want to know for sure that you can do the last page of the test, this is it. If you can do this, you're ready for the last page of the test. And then you just need to pick up the concepts. So guys, we have about 8 minutes left. I would encourage you to get started on the homework. We will gather up on Monday, turn in a bunch of stuff, and take a test. Go get them.